My name is David, and I am a developer advocate at Pulumi. Today, I want to introduce you to the Pulumi Challenge. Not only introduce you, but guide you through start to finish so that you can see how you can also complete the Pulumi Challenge and win an exclusive piece of swag. So, what is the Pulumi Challenge? The Pulumi Challenge is a set of exercises that will introduce you to Pulumi, trying to solve a relatively real world scenario. That is, deploying a static website to Amazon's S3, fronting it with CloudFront CDN, adding HTML and web checks with Checkly, and all at the same time showing you some cool, unique features of Pulumi, such as dynamic providers and component resources. So, enough of the chat, let's dive right in. Okay, so how do you get to the Pulumi challenge? First, go to pulumi.com/challenge. From there, you'll see our current challenge and some upcoming challenges. Select Startup in a Box, and you'll be presented with this screen here. All of these challenges are step-by-step instructions that allow you to construct a full Pulumi program that solves a real-world problem. The first thing we have to do is check off the prerequisites. Pulumi account, check. AWS account, check. Checkly account, checkly. Come on. So step one, we want to create our first Pulumi program. We're going to run Pulumi new, and then we provide a template name. The template name for today is AWS-TypeScript. We can leave the project name, which is generated based on the directory, accept the default description, and I'll set my stack name to production, because you only live once. Next, I'll set EU West 2, as I am in Scotland, and we will let npm install the dependencies. Next, we want to create our first resource. Here, we have the code to create an Amazon S3 bucket and an ACL to ensure that the contents of our bucket are available for public read. This means the S3 bucket can be used as a static website. When we generated our Pulumi program, it creates some basic resources, also an S3 bucket, so that to help you get started. We're going to remove that and paste in the code from the challenge. Next, we'll want to just rename this bucket to be something that is universally unique and makes sense for you. For me, I'll do Pulumi challenge David 1. That should be okay. Next, we're going to add some code to populate our S3 bucket with files. Now, because Pulumi uses the standard Node.js APIs, we can use those APIs ourselves to read files from the disk. So we can copy this code here and drop it in here. And all this is saying is that we need to import the file system APIs. We set a constant for the directory. And then we're going to do an fs reader sync. This just means synchronously get me a list of all the files within a directory. We can then create a new bucket object based on that file. Remove the extra copy, and we should be good. Now, because we're using VS Code, which has access to language server protocol, which has really great support for Node.js, JavaScript, TypeScript, etc., we can see that we have an error message in our code. This is telling us that it can't find MIME. To fix that, we can do an npm install MIME, and because I'm using TypeScript, I can add types MIME. We hit return, and those packages are installed, and then we come back here and consume them just like regular JavaScript code. We hit save, error message goes bye-bye. Next, we have to copy and paste some static resources for our website. So first, we have our index.html. Remember that we need a directory called website, which needs a file called index.html. Next, we need to add style.css. Lastly, we copy normalized CSS from GitHub. We click the raw button, copy all, and drop in. Now, it's probably about time we try a Pulumi up and make sure there are no unexpected errors. First, we could run a preview. And this looks pretty good. It's telling us that it wants to create a new bucket with an ACL and upload 3 bucket objects, the 3 files that we just copied into the website directory. Next, we can run Pulumi up, skip, preview. And that's it. All right, let's carry on. Next, we want to expose our S3 bucket through CloudFront CDN. This is great because egress costs of S3 buckets can add up to be rather expensive. Fronting your S3 bucket with CloudFront means that you get to distribute all of those assets to edge locations all around the world where the assets are cached and delivered with great performance as close to your customers as possible. So let's add CloudFront in front of our S3 bucket. Now we can copy this, jump back to our code, and just paste it in. We'll see here that we configure the origins using our bucket's original domain name. Everything else here is pretty much boilerplate, and we don't need to worry about it. Now, creating a CloudFront distribution does take a little bit of time. So let's start that now and carry on. Now, we can test that this works by popping down here and saying export const URL equals CloudFront distribution domain name. The domain name on the CloudFront distribution is an output property that is available after the resource becomes under management. And if we save this file and run again, we'll see that there are no changes to make other than exposing the URL. You can also run Pulumi stack output to reference these values at any time. There's also a neat JSON flag if you want to be able to consume this programmatically. Next, we can curl the CloudFront URL and we'll see the HTML from our static website. Nice, right? But because we're using Pulumi for our infrastructure, things can be a bit nicer. Step 5 introduces us to component resources. Let's copy and paste all of this, and then we'll run through it quickly. So what's happening here? Well, first we're creating a new class called CDN website. This extends the Pulumi component resource class. This provides all of the boilerplate that Pulumi needs to understand that a component resource is a logical grouping of other resources. We can set some properties on this class. Here, they're just all private and used only within the class itself. And then we need a constructor. When we call the super constructor, we can provide a resource name, here, Pulumi challenge CDN website. And then we just propagate all the other properties right through to that super constructor. The next thing we do is just create the exact same resources. First, we create the bucket, then the ACL, then the CloudFront distribution. This is all the exact same code, except for one small change. This last parameter to all Pulumi resources allows us to provide resource options. One of the resource options we can provide is a parent resource. For each of these resources, we're providing a parent of this being the component resource itself. This allows us to structure and visualize the hierarchy of our resources when we run Pulumi commands. So how do we consume this? Well, first we go back to index.ts and we delete everything. We jump back to the Startup in a Box Challenge website and click copy. Here, you have to make sure that the name of the file that you pasted your code into matches. This file has an export called CDN website, which is a class that can be constructed. We can provide a name for this resource. So let me challenge 1 and hit save. And that's it. And in fact, if we come back and run Pulumi up, we'll see that it's going to delete all of our old resources and create new resources. But more importantly, let's notice the hierarchy. These resources that are being deleted are all a flat hierarchy, meaning they're all one after the other with no tree structure, no hierarchy. However, take a look at their new resources. We have something called the Pulumi Challenge CDN website, which creates a bucket. This bucket has 3 objects. The bucket also has an ACL and a CloudFront distribution. The Pulumi preview gives you this hierarchy, giving you more context and understanding of the resources and how they interact together. So let's hit yes and let it do its thing. All right, old deleted, new spun up. However, we've lost our URL. Fortunately, the component resource that we defined provides a getter method for that output variable. So we can add back our export const URL equals website and our getter method URL. A quick run with skip preview will get us that URL in no time. Now we can copy, curl, and we're back in business. Awesome. Next, we're going to add a new provider from the Pulumi registry. This is the Checklay provider. Checklay provides a great service that allows you to run HTTP-based checks or API-based checks against your software by simply doing an npm install and then setting our secret and paste. Now we need to set our Checklay account ID. This is not a secret, but we can type it in plain text. Now we can add some code to configure our Checklay check. So now we can just paste in the code from the website. Now here we expect something called website URL. However, we only have it available as URL. So I'll update that, delete this extra copy, and hit save. And that just works. Now what this is doing is saying that we want to create some check called index page, which runs every 10 minutes. It's a browser-based check, and we want to run it in the AWS region EU West 2. Now the script itself, we could use a string which has JavaScript code inside of it. However, then we lose access to VS Code, language server protocol, and syntax highlighting. So our preferred approach at Pulumi is to fs read file sync the check. So we can actually create the file checklay embed.js. So now we just have to copy the code from the challenge website. We can scroll down to here. We have syntax highlighting, which is great. Now we're not going to have autocomplete because we don't have playwright or expect as part of our dependencies. However, you could open your package.json, add them as dev dependencies, and those would be available. Here, we're using a handlebar style mustache syntax so that we can interpolate that value from the Pulumi code. Because our website URL is computed. If we jump back to index.ts, you'll see here we just do a replace with the URL. Now, because this is a computed output value, we don't actually have access to the raw string, which is why we're using Pulumi apply. This gets built into the DAG and execution lifecycle of the Pulumi program so that when the string is available, we can read this file. So let's test that this works. We can run Pulumi up and we'll keep the preview. The preview shows us that we have one check to create. We can hit yes and let it go. Awesome. The last section of the Pulumi challenge is to implement a dynamic provider. This is for when you want to work with an API that there is no existing provider within the Pulumi registry, but you don't want that to slow you down. Using Pulumi TypeScript or Python, you can write dynamic providers in just a few lines of code. Let's take a look. First thing I'm going to do is copy all of this and drop it into a file. We'll call this swag.ts and hit paste. So what we have here is an Airtable webhook URL, which we're using to collect all of your entries in the Pulumi challenge. Because we're using TypeScript, we can define our interfaces for all of the inputs and outputs, or DTOs, that we need across all of our different classes, before lastly implementing a swag provider, which implements a dynamic resource provider. A dynamic resource provider is any class that implements create. In fact, if we click on the resource provider, you'll see that we have some optional methods: check, diff, read, update, and delete. Create is the only one that is mandatory. It can take any input and returns the create result promise. So you can implement your own dynamic providers with a single function. We've got some red squiggles because we need an HTTP library, which comes in common JS format. For that, we're going to use a specific version of GOT. So in order to add that version of GOT, I'm going to open our package.json and add GOT 11.8.0. This was the last version of GOT that comes in common JS format. We can now run npm install. And if we jump back to our code, the squiggles go away. So on our create provider, we require GOT and we launch a post request to our Airtable submission URL with some headers and some JSON properties that are passed in as resource properties. We know that the swag create response that comes in JSON format, and GOT handles that all for us through its generic types. Next, we just return the create response. Next, we need a little bit of glue that tells us how we can construct a new swag provider and resource. If we jump back to the Pulumi code, the Pulumi challenge, you'll see the invocation code here. So let's go back to index.ts and underneath our check, paste this. Update your import to match the file name that you used and fill in the form. I'm David Pulumi, and david@pulumi.com. I'm not going to fill in my address, but now we can specify the size. I'll pretend I'm a large. We save this, and now we're going to run our Pulumi preview. We can see here that we have a dynamic resource called David Pulumi. Let's run up with a skip and give it just a moment. Voila. We've now completed the Pulumi challenge. We've taken a look at deploying a static website to S3 fronted by CloudFront with real-time HTTP browser-based checks from Checkly. We structured that with a component resource, giving us a nice visual, contextual hierarchy of resources from the Pulumi CLI. It was then integrated with a random API on the internet, in this case Airtable, to be able to pass your information so that we can send you a cool bit of swag. We do this with a dynamic provider and only a few lines of code. We think this is pretty cool. We hope you've enjoyed the Pulumi challenge, and we'll see you for the next one. Have a great day. Here's a bonus tip. If you write an article, publish a Twitter thread, or make a video on completing our Pulumi challenge, email us at da@pulumi.com because we've got some special swag just for you. Have fun.